All right, so the first thing I want to talk about is a lot of people will say graph and they'll think unit circle, which is great because it is a type of graph. But when I talk about graphing a sine function, what I mean is if I were to say sine of x and you plug in a value of x, what's the y value you get out? So like if I were to say like my x value is 30 degrees, then if I were to put in 30 degrees, I would get out 1/2 because that is the sine of 30 degrees, okay? So now instead of thinking x, y as far as on the unit circle, what I'm actually talking about is if I were to just use sine of theta, then my input is going to be the angle and my output is going to be the sine ratio. So like if I were to put in 0 for sine, then I would get out 0. If you look at your unit circle, the sine value of 0 degrees is 0. But if I were to put in pi over 4 into sine, and that's my input, then my output for pi over 4 would be square root of 3 over 2. All right, so you can see, even though it's not, easy to graph, square root of 3 over 2, you can see that it's about there. At pi over 2, if I were to put in pi over 2 for sine, then my output for that would be 1/2. If you look at your unit circle, the value of sine for pi over 2 is 1. And so if you'll look here, if I put in a pi over 2, I get a 1 as my y value. And so if you do that all the way around the unit circle, so just picture taking your unit circle and you are just putting the angle measures here on this x-axis. The y-axis represents the sine value you get, okay? And so what you'll notice is it creates a wave. Both sine and cosine are waves. They're wave values, all right? And so when you graph them, sine starts at 0, it goes up to a peak, it goes back to 0, it goes down to a valley, and it comes back up, and it will do it again, all right? So if you study like sound waves do the same thing. And we're going to talk about some of the same terms that you would hear if you were talking about a sound wave. You're talking about the frequency, how often it happens, the period, how long it takes to go through one entire cycle. So we're going to talk with some of those things because all of your wave functions will do the same process. All right. And so this is what sine looks like. You'll notice that if I start at 0, I get to half a circle, I'm back at 0. Well, if you look on your unit circle, the sine value at 0 is 0. The sine value at pi is 0. And when you go all the way back around to 2 pi, the sine value again is 0, right? And so you can see that that's what's happening. In the first and second quadrant, so from 0 to pi, my sine value is positive, right? And then in the third and fourth quadrant, from pi to 2 pi, my sine value is negative, right? And so you can look at your unit circle and then plot those points on a coordinate plane. And you can say, okay, here's what it looks like if I'm just graphing the sine. Input is my angle, output is my sine value. And that's what it's going to look like. It's going to be a wave. And so on the handout that I gave you at the very bottom, you're going to see sine, the sine graph here. All right. I want to talk a little bit about what happens with the sine, okay? So the sine graph will always start at your midline. Your midline, when it's not shifted in any way, shape, or form, is your x-axis, all right? So the best way to graph these is to divide them into quarters, all right? So what I typically do is I find the starting point. So just for a standard sine graph, the starting point is going to be 0. We're going to do some shifting, but if it hasn't shifted, the starting value is 0. It will complete an entire cycle by 2 pi, all right? So that's where it starts over. That's my beginning and my end, all right? In order to graph, I'm also going to mark the halfway point, all right? In this case, if I'm going from 0 to 2 pi, what's halfway across from 0 to 2 pi?
1.
Yeah, 1 pi. So that's my halfway point. I'm going to mark that. And then I'm going to mark my quarters by simply dividing my halves in half, right? So for this particular graph, my first quarter is at pi over 2, and my third quarter is at 3 pi over 2, all right? So that's why I'm going to mark those when I'm graphing a sine graph. And I'm going to start at my middle, my midline. My first quarter is going to go to my highest point. Halfway, I'm going to be back to the middle. 3/4 of the way, I'm going to be at my lowest point. And at the very end, I'm going to be back at the middle. And then you're just going to connect those with that wave, all right? And so if you can find your starting and ending point, your halfway, your second and third quarter, you can graph your sine graph, all right? It's just a matter of knowing where those are. So for a standard sine graph, just sine, it's always going to be 0 to 2 pi that you're going to be doing that with. But we're going to do some things where we shrink it, or where we shift it, or where we go up or down with it, translating like we've done with other functions. And so all you have to do is find your starting and ending point and mark those as well. All right, so the first thing we're going to talk about, so look at cosine. Cosine looks very much like sine. It just looks like it got shifted, which is exactly what actually happened. It's a wave, but instead of starting at 0, if you look at your unit circle, what is the cosine value at 0? Cosine value at 0? 1. So then the cosine value at 2 pi is also going to be 1. All right? Now, cosine does a little bit different. In your first quadrant, cosine is positive, right? In your second quadrant, cosine is negative. In your third quadrant, cosine is negative. And in your fourth quadrant, cosine is positive. So you can see why it's going to do this piece right here. All right? Once again, you are going to find your starting and your ending value. You're going to find your halfway point. All right? And then you're going to find your first quarter and your third quarter. For this one, you start at your highest point. First quarter, you go to your midline. Then you go to your lowest point, back to your midline, and back up to your highest point. That's a cosine graph. So basically, cosine, if you were to look at them, they just kind of shift by 90 degrees from a sine. And that's what happens in the graph. It just shifts by 1/4. And so we're just 1/4 away from where sine would be. All right? So on your handout, let's talk about some of the terms. Some of the terms. Amplitude. The first thing I want to point out at the top of these notes is the standard form of a sine and cosine function. So you have a sine of bx plus c plus d. All right, these are all things that you could translate from a regular sine of x graph. All right, the amplitude is going to be the distance away from your middle, and you're going to look at that standard graph and you're going to do the absolute value of a. If there is a number in front of sine, that is your amplitude, and it tells you how far away from your middle you will go. How far away from your middle you will go. All right? So how far it goes up and down from the midline is actually what that's called there, midline. All right? So if you look at a standard graph, the highest value you get to is +1, and the lowest value you get to is -1. So on a standard sine function, the number in front of sine is simply 1. And so you assume if it doesn't have a number in front of it, that it is just going to be a 1. All right? Period. Period is how long it takes for the graph to complete one cycle. And when you're looking at your function to do the period, your shortcut is just to take 2 pi, which is your standard cycle, and divide it by b. B is the number in front of your variable, or in front of your angle. 2 pi over b. That's going to be how long it takes to do a complete cycle. 2 pi over b. All right? And once again, if you look at a standard sine, a 1 is in front of the x, so that's what your cycle is 2 pi divided by 1, which is just 2 pi. All right, so let's see some of these graphs. I just want you to state the amplitude and the period for these, all right? On a quiz or test, what this is going to look like is I'm going to ask you for different pieces of this. So the first two pieces that we've learned so far are amplitude and period. And so you would actually list out amplitude and period. And so you're going to say, well, the amplitude of this is just the number in front. That is going to be 3. All right. The period for this one is going to be 2 pi over that 1/2. Keep, change, flip, so the period's going to be 4 pi. All right? So before you do anything with graphing, the first thing you want to do is figure out what your amplitude and what your period is for something like this. We'll do some more shifting in a little bit, but for this piece of it, that's all we're doing, okay? So amplitude and period. How does that help me? Okay, so period tells me how long it takes to do a complete cycle. All right? How long it takes for me to do a complete cycle. So when I say find your starting and your ending point, assuming we're not shifting left and right, which we are not for this one, I am going to start at 0. All right? And then my period tells me where to end. So if I start at 0, the length of my period tells me where to end. So I'm going to end at 4 pi. So you want to mark your starting and your ending value, starting and ending points for this graph. So mark 0 and mark 4 pi. So I've marked my beginning, I've marked my end. I'm going to mark my halfway point. My halfway point for this guy is going to be 2 pi. All right? 2 pi. Once you've marked your beginning, end, and your middle, you want to mark your 2 quarters. In this case, pi is going to be my first quarter. 3 pi is going to be my third quarter. All right? All right, so for a cosine, that is what we're doing right now, is a cosine. If you'll remember, or if you look at your little handout, cosine starts at the highest value, okay? Your amplitude is going to tell you what your highest value is. It is going to be that many units away from the middle. And this particular graph is sitting right on the x-axis. We are not shifting it up or down. So we're going to start at the middle right here, and we're going to say my amplitude takes me 3 up. All right, for cosine, we start at the highest value. So I am going to put a mark at 0, 3. 0, 3. At my first quarter for a cosine, I am back at my middle. So I'm going to put a mark right on the x-axis. This is why it's important to know these quarters. At the halfway point for a cosine, I am at my lowest point. My amplitude also tells me my lowest point. I am going to be 3 units away down at my halfway point. So I'm going to go to -3 and mark it at the 2 pi, my halfway point. My 3/4 point is back at my middle. So I'm going to mark the x-axis. Okay? And then cosine ends at the highest point, which is back up at 3. Now, this is important because this is not an absolute value graph. You should not have V's or sharp turns. This is a wave. All right, so this is just trying to tell you how to sketch this. You're sketching a wave through that. So you are going to then start a little before, and you're going to sketch your wave. And you're going to go down. It's going to curve right there, come up, curve right there. You want some arrows showing me that it is a cycle, and then it continues, all right? So this is a wave function. It's not an absolute value. It shouldn't go down in a sharp point and up in a sharp point. That's actually a different function, okay? All right, so if I were you, I would probably make some notes. So I would do something like sine, right? And I would say start, and then middle, right? First quarter, it's going to be at the highest. Halfway, it's back at the middle. Third quarter, it's at the lowest. And it ends at the middle, right? That's a sine graph. We just did a cosine graph. Cosine graph looks different, right? For cosine, it starts at the highest, right? First quarter is at the middle. Halfway is at the lowest. 3/4 is at the middle. And it ends back at the highest. All right? So if you know those quarters and those markers for these graphs, then all you have to know is how to find the amplitude. How high do I go? How low do I go, right? How do I find the start and the end so I can mark off my half and my first quarter? That's your period, okay? And so if you can learn those quarters and memorize that, then the graphing piece is not difficult. You just have to mark them off and sketch it, all right? So there are two other ways you can shift your graph. You can actually move it up and down, or you can move it left and right, all right? And so up and down's really easy. Up and down is just if anything's added to the outside. So the first thing we're going to talk about is the vertical shift, even though it's not listed that way on your paper. Vertical shift's really simple. This determines where the midline will be. So if it's not shifted up or down, your midline is just your x-axis. But if it is shifted up and down, you need to draw like a dotted line so you can get a visual of where that starting point is, all right? And that's really easy to find. If there's any number that is added or subtracted on the outside, that is your midline. That is your vertical shift. It can go up or down, all right? So whatever D is, that is where you're going to set that little midline or your starting value, all right? All right, your phase shift. You can think of this as your left and right shift. So your vertical shift is your up and down shift. Your phase shift is your left and your right shift, okay? This determines where to start the graph in relationship to the origin. So normally we'd start at the origin and we would end at the period, okay? But if you shift left and right, you may start at pi over 2. And instead of ending at 2 pi, you end at 2.5 pi, right? Because you've already shifted it over. All right, so it tells you where to start, and then you just add your period to it to figure out where to end if you have to shift it left and right. This one's a little bit different. All right, so remember left and right shifting for other graphs is inside the function. So we are going to use the numbers inside the function, but it's always opposite of what you think. So we are going to use that C, but we're going to say negative C, and you have to divide that by B. And that will tell you what your shift looks like. Negative C over B. Negative C over B. If B is already on the outside of your parentheses, it's already been divided out. But typically when I give them to you, your b will be inside like this. If you ever see it written like this, a sine of b on the outside, then you don't have to divide it by that b. It's already been taken out, right? It's already been pulled out by distribution. But if it's still inside, you have to divide him out. And that tells you your left and right movement. All right, so let's go through the steps. You want to find all of those things listed above. You want to find your amplitude. You want to find your period. All right. You want to find your phase shift and your vertical shift. So you're going to write all of that out before you start graphing, all right? You are going to use your period and your phase shift to find the starting and ending point. And I'll show you how to do that in just a second. That did not come out right. You're going to find the maximum and the minimum using your amplitude and your midline or your vertical shift. Your midline is what tells you what your middle point is. And then once you do all of that, you're going to graph the function. All right? So we're going to write out the list of things, then we're going to mark them on the graph, and then all you have to do is sketch from that point on. All right? So let's look at an example. So if I do my amplitude 2, my period is 2 pi over pi over 2, and I keep change flip, all right? Keep change flip. Does everybody see how I got 4, right? 2 pi divided by pi over 2 is times 2 over pi. So I'm going to get 4 there, right? Keep change flip. 4, since my graph is in terms of pi, well, 4 is going to be a little past 1 pi, right? So 1.5 pi would be like 4.5-ish or so. So we're going to go in between pi and 3 pi over 2. We're going to estimate that when we do our shift there. All right, so we have my amplitude and we have my period. Let's do my phase shift. Remember, phase shift is going to be negative c. Negative c is positive 3 pi over 2. And we are going to divide that by pi over 2. All right, keep change flip. What does my phase shift look like? Or you can just cancel out my pi over 2's. Phase shift is 3. All right, phase shift is 3. All right, and then vertical shift. Vertical's easy. What is my vertical? It's just the guy on the outside, right? Positive 1. All right? Positive 1. All right, so the first thing I typically do is I draw my midline. All right, so I go to this vertical shift and I draw whatever it is. I draw a y equals that number. That's my midline. All right, so I draw that guy right there. That's my vertical shift. He went up by 1. All right. The next thing I do is I look at my amplitude and say, how far away from that line am I going to go up and down? 2. I'm going to go 2. So what is 2 up from 1?
3.
Yeah, and what is 2 down from 1? Negative 1, right? So those lines tell me my highest and my lowest values, okay? Those lines tell me my highest and lowest values. My phase shift tells me where to start, okay? Normally I would start at 0. I'm going to start at 3. 3 is going to be just a little bit before pi, yes? If pi is 3.14, then 3 is going to be about right here. Everybody see my starting value? Yes? Starting value is 3. My phase shift is 4. My period is 4, which means I start at 3 and I end at 7. All right? So if this is 2 pi, that's about 6.2. We'll say 7 is about right here, just past the 2 pi. All right? So this is my starting and this is my ending of my cycle. Starting and ending. So I have found my start, I have found my end, okay?
So the vertical, how did you get
4 away from there.
Okay.
All right, once I have that, you can eyeball where you're gonna mark your middle, okay? So mark about halfway through. So just look at this guy and say, where's about halfway through, right? And so it's gonna be a little bit to the left of this. So that's about halfway. And then mark your quarters. And again, you're estimating those, it's fine. So mark your halfway and your quarters, all right? And then we need to look at the graph. Which one are we graphing, sine or cosine? We are graphing cosine, right? So remember, cosine starts at the highest, yes? What did we say my highest was? Right here. So I am going to start at my starting point. I'm going to go to my highest value. There it is, all right? Highest value. First quarter. What did I say first quarter was? Your middle, right, for a cosine. So at my first quarter, I'm going to go to this midline that I drew. All right? Halfway for a cosine. Remember on your sheet, halfway is your lowest value. We already marked our lowest value. So to your halfway point, go to your lowest value right there. 3/4. 3/4 goes back to the middle. So at your 3/4 mark, go back to the middle. End. Cosine ends at the highest. Go all the way up to the highest. And all you have to do is sketch it. You've marked all your points. So then connect those dots with curves. Curve at the top, go down, curve at the bottom, go back up, and curve back over. Make sure you have your arrows that tell me that that is a continuous function. It keeps going. So it's very, very, very important for you to know those quarter markers that we talked about, that I wrote on the graph, because that's how you're going to be able to sketch these. So you look at phase shift, this tells you where to start, and period tells you where to end from your phase shift. Okay, you just add to it. And then you mark your half and your quarters.